What can you see in this video series? Creating a simulation for a functional microprocessor. I will use the Intel 4004 instruction set as a basis. The Bizicom 141 PF calculator is to be brought to simulated life. In this video we will create our first component, the switch. We create this in Python only. We create the mesh, the materials, and the shape key. We now write a method that calculates the points of a circle. I won't explain the Python code here. If you want to know more about it, you should search for list comprehension. Each point corresponds to a vertices. And this consists of three values: the x, y, and z values. What I explain here is what function the magic numbers fulfill. The number variable corresponds to the angle that the point on the circle should have. The step size determines the number of points. Reducing the step size increases the number of points. The number decreases accordingly if you increase the step size. A value of 10, which corresponds to 36 points, is sufficient for me. The starting value is also the first point of the circle. However, the final value is not the final point, but of course it has an influence on it. This value corresponds to the position on the z-axis. This is the radius on the y-axis, which is one of the semi-axes of an ellipse. Of course, this corresponds to the radius of the other semi-axis. Since I need 6 circles for the switch, I replace some of the magic numbers with parameters. First of all, this includes the radius, which should be the same on both semi-axes. What turns an ellipse into a circle? The second value I will pass is the position on the z-axis. Now let's write the method that turns 2 circles into a cylinder. First calculate the vertices for 2 circles. The faces consist of 4 vertices. The positions of the vertices in the list of vertices are required. The vertices are needed in turn. And always 2 from the lower circle and 2 from the upper circle. At the end you still have to create the face between the beginning and end of the circles. Since there is only one vertices and face list, both are still connected. Let's see what the magic numbers do. I make parameters out of the 4 magic numbers. These are the 2 radius and the height on the z-axis. This method is needed to move the numbers of the vertices backwards in the faces. This is necessary because all faces of the cylinders point to the first cylinder. We use this to create the mesh. The first cylinder is the base of the switch. I will define the corresponding parameters afterwards. I do this in case the appearance needs to be adjusted later. Then there is a small truncated cone at the top of the foot. And finally the button. For the top of the button we need to add a face. For simplicity's sake, I'm using a simple n-gon here. All vertices of the last circle are simply added. Now we create the mesh. If the name already exists, the counting continues as is typical for Blender. Now let's define the values for the appearance. First, the lower value for the foot of the switch. Then the upper value of the foot. This value is the width of the ring at the top of the foot. The bottom part of the button should be in the middle of the foot. The button has a height of 0.7 Blender units. The radius of the button is determined here. The foot is twice as thick. Now let's create a material. Since I will be using this material twice, we pass the name, color, roughness and metallic. First we test whether the material already exists. Unlike the meshes, we can use these for all switches. If not, we will create a new one. Of course we use nodes for our material. A standard material is created as usual. For simplicity, we delete the nodes and links. This is how you create the material output node. We then create the principled BSDF. Here we set the value of the base color. The default value is the value that can be entered directly. Then comes the value for roughness. And finally metallic. We move the node a little to the left. For the optics. Then we connect the BSDF output to the input of the surface of the material output node. Now we create the material that will show us the status of the switch. At the beginning we do the same as before. Since this material is only used once, we don't need any parameters and specify the final name directly. We create the material output node again. Then we create an emission node. We set the strength to 1 and move it to the left. Then we create a mix node. We set the data type to RGBA and the blend type to mix. We activate the clamp underscore factor and deactivate the clamp underscore result. Now we set the two color values to red and green. To move the node to the left. Now we create another attribute node. We set the type to object and the name to state. I'll explain in a few moments what state is and where it comes from. We are moving this node again. Now we connect the nodes together. Using this method we now want to create the materials and bind them to the object. Obj is the created object. You will find out how this happens a little later. Each object has a list of materials. The first material will be a gray metal. The second material will show the status. The final material will be a black plastic-like material. The polygons are the same as the faces. We have 3 cylinders with the same number of faces plus the final face of the button. We calculate the number of a cylinder because each of them should have its own material. The base should be metallic. We now smooth out the surface. The border is intended to indicate the status. We smooth here too. The button should look like plastic. We smooth here too. The materials are now created. For fun, let's now create a shape key for the button. For this we need the mesh and the object. First we create the base shape key. And then the key we need. We now get the generated key from the mesh. We calculate the number of vertices per cylinder again. For the button we now add a value for the Y value which is then created in the switch class. The effect of the key is this. Next we create a driver for the value of the key. In this we create a variable. Then we get this variable. We set the type to object. And set the ID to our object. As a value we enter this mysterious state again. We insert the variable as an expression. Finally, we set the useSelf value to true. We have now created the shape key. Now we write the method to create the object. We take advantage of the mesh and create a new object called switch. We then create the property state. The type is determined by the assigned data type, here integer. We can now assign too many values to this. But we only need 0 and 1. For reasons not explained here, I use integer instead of Boolean. With these lines we limit the property to the desired values. We now create a type property with the value switch. We'll need these later in this video series. Finally, we extend the execute method and put all the parts together. First we get the mesh and use it to create the object. We then add the shape key and the materials. Finally, we add the switch to the scene. We change the message and our first object is ready. We are now testing our switch. Everything works as expected.